All right, this is Algebra 3, review 8B. Okay. I don't know, this is 2020, 2021. I don't think we're just going to be one part. So check Nyasi, check 2, 3. All right. We need to cover question 13 first because it's not in either of the older videos. Okay, 13. It starts off, it says Greg is 8 years younger than Marcia. Greg is 8 years younger than Marcia. Hold on. Oh, Mariana's not here. I wonder if she would like to. She might actually join. Give it a second. David's not, I know this is all getting recorded right now, but David's not dead. It just means that his life is mine. All right. Okay, listen up, my turn. Greg is 8 years younger than Marcia. So in order to get Greg to be the same as Marcia, we have to add 8 years to Greg. Okay, does that make sense? Okay, Greg is 8 years younger than Marcia. 6 years ago. Okay, so 6 years ago, we are subtracting age. We are younger 6 years ago. 6 years ago, Greg was half as old as Marcia is now. There's Mariana. And David's life is mine. All right. Let's see. 6 years ago, Greg minus 6 was half as old as Marcia is now. The only way to get Greg to be the same age as Marcia is now is to double that. Okay, does that make sense? So there's actually two ways to solve this based upon how it's currently situated. Notice that both equations are equal to m. So we can set both equations equal to each other, right? And that's going to solve for Greg. But notice that the question is asking us to solve for Marcia's age. So once we have Greg's age, we can simply plug it in, solve for m. So I would go ahead. That's the way I prefer to do this one, is do the 2g minus 12 equals g plus 8. Does that make sense? Probably. And the question was, is the question on the test going to be like that? I'd say likely. But I'm going to show you the other way, which you already know, is that we can solve this using a matrix. Okay, so what we have here is that we would add 12, subtract g, we get g equals 20. Okay, come back up here. 20 plus 8 is 28. M equals 28. Right? That's pretty easy. Now, if you want to solve it using a matrix, I'm going to have to move this M over here and this 8 over here. So I'm going to get G minus M equals negative 8. I would come down to, well, really, this part of this equation with that M. So I would get 2G minus M equals 12. So my RREF matrix is 1, negative 8, 2, negative 1, 12, I believe. So that's what it should be. And then RREF. And what we should get out of that is 0, 0, 1. And because we already know Greg is 20, 20 should go here. And 28 should go here. This being G, this being M. Us wanting this. Okay, so if it doesn't come out exactly like our first form, right, you should still be able to solve for the matrix form of that, right? Put everything in standard form, put it into your matrix, and solve. Questions about number 13? Nope. Okay. All right, so we want to pick it up with questions that were most missed. Okay, so you get to see these more than once. You're going to need your graphing calculator for number 5. Okay. So let's see, this comes out as 9 15 degrees plus 6, 55 degrees. We start by plotting this. Okay, so 15 degrees looks like this. The hypotenuse of 9. Over here, we've got 55 degrees. Okay, for my reference angle with a hypotenuse of 6. I need to solve for x, and y, and add them together. Okay, how do I solve for x? 9 cosine 15 cos. Okay, how do I solve for y? 9 sine 15. Okay, which I'm guessing you do tangent okay, right? It's not tane. 9 tane. Okay, and then we're going to come over here. We should get the same approximate thing. 6 cosine 55. 6 sine 55. We want to solve these to 4 decimal points. Okay, just because that's how they do it. So, all right, so 9 cosine 55. I'm just going to, you'll get these numbers, but I don't really want to wait on somebody to finally punch these in. You need to make sure that you're in degree mode to get the correct numbers. So I should get 2.329. I don't guess I have a 4th decimal there. I only went to 3 on mine. So, all right, 9 sine 15. Oh, I'm sorry, I got that backwards. 9 cosine, that would be 8.693 and 2.329 here. 6 cosine 55 should be 3.441 and 4.915 here. Okay, now all I really need to do is just add my x's, add my y's. Okay, so I should get 12.134. That'd be I plus 7.244 J, and that's your rectangular coordinates. Okay, but we're not done because we need this in polar coordinates, which means we need the hypotenuse and we need the reference angle. Okay, so we bring this down here. We can tell that they're both positive, so we should be in the the first quadrant. So 12.134, 7.244. We need a hypotenuse. We find the hypotenuse here by using the Pythagorean theorem, which gives us the distance formula, x squared plus y squared. So 12.134 squared plus 7.244 squared. Okay, we should get a hypotenuse of 14.132. Okay, I bring that hypotenuse over here, 14.132. Okay, last step, how do I find the reference angle? Inverse tangent. Tangent, opposite over adjacent, right? What is opposite in this case? Okay. 7.244. Another way to think of it is tangent is y over x. 12.134. Okay? Again, if I'm in degree mode, I should get a good answer of 30.84 degrees. Okay, and that's what we want. It is a lot, but the more that we do this, the more we should see the pattern in what we're doing, the easier it is, even though it's more steps. Okay. Mariana, did you got your review done, right? I think I saw you send that to me. Okay. All right, so that was 5. Let's see, let's look at 11. Okay. 11 is just, it's a lot of steps, but it's basically, do you know how to add and subtract fractions? Do you know how to divide fractions? That's all it is. Okay. Just over and over again. 1 over, let's see, what was this? Number 11. Okay. 1 over a plus 3b over 2 plus 4 over x. Okay? So what's the first thing I'm working with? Okay? So what would we say that we're doing here? Get a common denominator, right? So what we're kind of looking for here is I want you to be able to see that you're adding fractions, okay? Even though you need to understand that a whole number is still a fraction. Okay, so we've got 2 over 1 plus 4 over x. What is the common denominator? X. X over x. So that's giving me what? What is my 2x plus 4 over x? And we take that and we substitute it in for this, correct? Because it's equivalent. Okay, so I'm going to rewrite as 1 over a plus 3b over 2x plus 4 over x. Okay, what am I working with now? Say that again. Good. 3b over 2x plus 4 over x. Okay, I am taking 3b and I am dividing it by the fraction that we just solved for. I am multiplying by a reciprocal. So I have 3b over 1 times the reciprocal. X over 2x plus 4 is the reciprocal. Okay? And this is actually the easier part, right? Okay? Because what do I get for an answer there? Over 2x plus 4. And that gets substituted back in. So whenever I go to rewrite it, what am I rewriting? Or what am I? And you see how it's alternating between adding fractions and multiplying by the reciprocal? It just goes back and forth, back and forth, back and forth. Okay? All right. So what is my problem now? A over 1 plus 3bx over 2x plus 4. Okay? So what? This is where it gets a little bit more complicated. Go ahead. You're back to the very first, yeah, except you have a more complicated denominator. So when I go to get a common denominator, I'm going to end up distributing here, right? Because what is my common denominator? 2x plus 4 over 2x plus 4. So with the common denominator of 2x plus 4, right, I still have to distribute this 2x plus 4 to the a. So I'm getting what? Plus 4a plus 3bx, okay, which is substituted in there. Okay, now here's the really nice thing, and let me just kind of shortcut you here. Okay, this is going to be 1 over 2xa plus 4a plus 3bx over 2x plus 4. So the math there is 1 over 1 times the reciprocal, right? Right. So you really, at this point, all you need is the reciprocal of this right here. So your final answer is just 2x plus 4 over 2xa, or 2ax, whatever, plus 4a plus 3bx. Okay, so yeah, I mean, it's obviously a lot of work and a lot of places to get something wrong. I would say that your biggest challenge here is making sure that you follow your work and you can read your handwriting and that you don't lose things. So my suggestion on a question like this is don't put this on your box sheet. Get a scrap sheet, get a notebook sheet of paper and work this out where you have enough room to work it out. Because I think the biggest thing that costs a lot of you guys is you're trying to cram a lot of work into a little box, and you're erasing over things that you wrote, you got it wrong, but maybe you didn't do a good job of erasing, so you're seeing parts of answers from previous attempts and all that kind of stuff that's going to mess you up. Okay? So when you go to do something like this, make sure you have plenty of room to do it. Okay? All right. That was 11. Let's go back to 1. Ship sailed K miles per hour for 8 hours, 20 miles. Okay, so I always start these the same way every time, okay? Because there are patterns to these questions. So I write at the top, and I write down. And I do D equals RT, R equals D over T, T equals D over R. Okay? I don't know what I'm going to need yet, but I know I'm going to need one of those things. Right? Down here, I do distance, rate, and time. Okay? And now, we're going to read the question, we're going to take it slow, and we're going to consider what it is that they're giving me. The ship traveled K miles per hour. What is miles per hour? Is it distance, rate, or time? Rate. So for rate, I'm going to write K. Does that make sense? For A hours, what is A? Time is A. Now, so you're aware, on these questions, they will always give you two things that are straight out, okay? The third thing, whatever it is, will require me to use the ratios for distance, rate, and time. Okay, so in this case, notice that they didn't give me a distance. So that means that what they give me for distance, I'm going to have to use my ratio stuff for, okay? So notice that it says, and was 20 miles short. Well, one of the mistakes that I don't want to do is I don't want to write minus 20 in here. Okay? I'm not going to write plus 20. Okay? What I'm going to do is I'm going to look up here. What is distance? Distance is rate times time. All right? So I'm going to take K times A and subtract 20 from it. Okay, because distance is rate times time, and they said I was 20 miles short. Okay, so it has to be something that's being done after a known distance is given. Okay, all right, does that make sense? That's the tricky part to this question. Now we can look at the rest of it, because we need to look at what we actually want to solve for. If the Vikings tried again, how long would it take? All right, so what am I solving for? I'm solving for time, so I want new time. And new time is going to be new distance over a new rate. Okay? Now, we want to actually make it this time, right? So what needs to happen to my distance? Plus 20. So K A plus 20, right? Because we want to make it there. All right, now we need to look at our rate, correct? Now look at the rest of the question. If they increase the rate of travel by 35 miles per hour. So what's my rate already? Okay, and what are we doing to it? Adding 35. All right, and because we're solving for time, I need a label. What is the label for time here? Hours. Okay, so that's it. You can't solve for it. You don't have enough information. Okay? But what this is teaching you, it's teaching you how to write equations so that, let's say they gave you this and then they told you, okay, K represents, 5 miles per hour, and A represents 5 hours, right? Then you could solve everything else, right? Okay. Or if they even just gave you one piece and they just told you what K was, we could solve for A, right? Okay. All right. Number 8. Okay. So arc sine. What that means is that we're looking for a degree measure. Okay? Arc sine radical 3 over 2. So they're giving me the ratio. I have to find the degree. So I'm going to start by drawing a coordinate plane. Okay, both those numbers are positive, so which quadrant should I be in? First. Okay, so I'm going to give myself something like that. All right, sine is opposite over hypotenuse. And whenever we're talking about opposite on a coordinate plane, we're talking about opposite of the reference angle. Okay, So where should the radical 3 go? Should it go on the bottom, on the hypotenuse, or on the right-hand side? Right-hand side. Radical 3 should go right there, right? It's opposite over hypotenuse, so what does the 2 represent? The hypotenuse, so it goes there. All right, this should be familiar enough to me that I should know what's going on the bottom. 1. All right, all we want to know is what is this degree? 60. That's it. Now, you can use your calculator to check this. All right, so you use your calculator by hitting inverse sine. Okay, radical 3 over 2, enter. Now you have to be in degree mode, but go ahead and check it. Does it give you 60? Gives you 60. Okay, now let's look at the other one. This one's arc sine, but this time it's giving you negative radical 3 over 2, right? So we draw it. Okay, the opposite is negative this time, which means, right, it's down here. Okay, because my opposite is negative, but my hypotenuse is positive. Okay? Okay, so what is that degree? Negative 60. And I should still be able to check it. Okay, and it's negative 60 because we're going that way. I would probably even accept 300 degrees, right, if you showed going around that direction. Because technically negative 60 degrees and 300 come out, they're coterminal, they come to the same point. Because the y, right, the opposite is negative, so it's got to go below. Okay? Okay, any other questions? All right, 14. Uh, 14. I don't really want to show you 14, but you guys probably want it. All right. So they give you some here. I'll work it out. We'll do it. It's fine. Gives you something like this. X, M, Z, Y. Okay. To call a proof, in this, they tell you X, Y is to ZY. Okay. XY is congruent to ZY. So we can put that in. That's given. Okay. Statement, reason. Okay. The other given is MY is congruent to XZ. Okay. MY. MY. Hold on. Is that right? MY, XZ. Oh, hold on. Not congruent, perpendicular. That's why. MY is perpendicular to XZ. So what that means, but we'll have to state it. So we have a given here, but I can't draw in yet because I have to actually make a statement on this. Okay? Let's see. We're going to say angle XMY and angle ZMY are right angles. Okay? That's not a given. We have to state that triangles, let's see, perpendicular lines form right angles. Okay? The next thing, right, now I can say this. Okay? Okay? I can state that triangle XMY and triangle ZMY are right triangles. Okay? Triangles that have right angles are right triangles. Can you guys read that okay? I mean, it's just easier to do that than to actually write out the words. Okay? Okay. Now, if we're going to use right triangle congruency postulates, I need one more thing. Okay? And it's a really simple thing, but it's not something that everybody sees. And that is that right there. Okay? We should be able to say that ym is congruent to ym through what? Reflexive axiom. Okay? No, it's not side angle side. It's hypotenuse leg. Okay? Side angle side would have to go side angles, would have to have xm and zm in order to have side angle side. Okay? So we're going to say that triangle xm, well, let's see, what do they use here? Because we have to use the same statement that they wanted. Ymx is congruent to triangle ymz through the hypotenuse leg congruency postulate. So that one's a little bit more involved. But does that make sense? Let's see, right here. Okay. So I said angle X, M, Y, and Z, M, Y. What was your question? You can do YMX as long as you do YMZ. Okay? Because you want to use corresponding things going with each other, okay? All right. So that's number 14, 17. Y squared minus X plus 3 equals 2X. Okay, so this is a line and a hyperbole. Okay, so it would be something like this. So there should be two solutions here. Okay? Let's see, what I'm going to do first is I'm going to take this linear equation and I'm going to solve it for y. So I should get y equals 2x minus 3. Once I know what y equals, I can sub it in. So I can go 2x minus 3 squared minus x squared equals 9. So now we have everything in terms of x. On this first portion here, okay, the thing you have to be careful to remember there is that you're foiling. Okay, so that's 2x times 2x is 4x squared. Let's see. It'd be 2x times negative 3, which would be negative 6x. You'd get negative 3 times 2x, which would be negative 6x again. Negative 3 times negative 3 would be positive 9. Okay, then you have minus x squared equals 9. Right, you can combine like terms. You're going to get 3x squared minus 12x plus 9. Okay, plus 9, you got a 9 over on the other side. So we would actually subtract 9, okay, which is going to give you 0 equals 0. Okay, now at this point, what we should be able to do is we could factor out a 3. So we got 3 times x squared minus 4x equals 0. I'm not actually looking at anything, so I might be way off on some of this. Let's see. Let me look back at this question. What is this, 17? looks good so far. So we got the x squared minus 4x equals 0. Then we can factor out an x, okay, which is giving me x minus 4 equals 0. So we've got two options, x equals 0 and x minus 4 equals 0, or x equals 4. So we have two solutions for x. We have 0 and 4. So now I just have to solve for those two scenarios, okay? So coming back up here to our linear equation, what does y equal whenever 2 equals 0? Okay, 2 times 0, so that's 2 times 0 minus 3. So y equals negative 3 when x equals 0. So my first coordinate would be 0, negative 3. And then what does y equal when 2 equals 4? 2 times 4 minus 3. Y equals 5, you say? All right, so my other coordinate is, 4, 5. Those are your two coordinates. It's just that easy, folks. All right, so that's all of the main questions that I picked out that seemed like to be our most missed. From here on, with the time that we have remaining, which is about, 6 minutes, something like that, what do you want to cover? 15? Okay, 15. Y to the 2 minus b, y cubed to the b plus 1. Okay, let's focus on that for a second, okay, before we get into the rest. There's nothing I can really do to the y to the 2 minus b, so I'm just going to bring that down here. But this y cubed to the b plus 1, I'm taking an exponent to an exponent, so I'm going to multiply. So we're going to distribute the 3 into b plus 1. So I should get y to the 3b plus 3. All right, these two things are multiplying by each other. Whenever I have a common base in y and I have different exponents, I'm going to add those exponents. So I have 2 minus b plus 3b plus 3. Notice that this is just the exponent that I'm working with. So I'm going to combine like terms. I've got 2 plus 3 is 5, and negative b plus 3b is 2b. So my simplified numerator is y to the 5 plus 2b, or y to the 2b plus 5, either way. All right, now we can come down to our denominator, which is the cubed root of y to the 4b. Okay, now hopefully we remember how to pull things out from radicals, is that we take the exponent and we divide it by the root. So that would simplify to y to the 4b divided by 3. Okay, so this is over y to the 4b divided by 3. Does that make sense? Now, because we have two sets of y's, we want to get the denominator into the numerator. So we got y to the 2b plus 5 times y to the negative 4b over 3. At this point, I've got same bases, right? So I want to add their exponents. So 2b plus 5 minus 4b divided by 3. Okay, my like terms are 2b and negative 4/3 b. Okay, I could go ahead and make this a common denominator, which would be, what, 6/3? 6/3 b. So what's 6/3 b minus 4/3 b? 2/3 b. So I should get 2/3 b plus 5. So that would be y to the 2/3 b plus 5. Is that the right answer? Is that what's in your answer key? Cool. Cool. All right. That was 15. I can probably get another one in the next 3 minutes. What do you want? Nothing? All right. So I will send out this document in 3 review videos as soon as I can. All right, we'll stop it there.